Hello everybody, welcome to this video for PROG1198. Today's topic is views. So we're going to be taking a look at what a view is and how to create one. So a view in a database is a database object that acts like a virtual table based on a select query. So it represents data in tabular format with rows and columns. Essentially, a view is a way for you to create a custom data set. A view enables users to perform all database operations as they would on a table. It does not actually store the data though. So the view creates the data set when the view is called upon. We can use a view to represent any columns or rows in a single table or multiple tables. And as we take a look at some different types of views, you'll see that a view is based on a select statement. And it can be any type of select statement that you want to write. So we can use a select statement as the source query of a view, and that select statement can encompass things like joins, grouping, having, union, subqueries, where lines, and other conditional clauses. You can include calculated columns, any type of things that you can do in a select query. The only exception is that a view cannot include an order by line. So you can't control via the view how items are ordered. But that's okay because the view just creates the data set. When we select from the view, then we can apply ordering to it. So here's an example of creating a view. So we start off with a create statement, and then the word view, and we give our view a name. Now, typically, views begin with the prefix VW underscore, or sometimes you'll see it as just V underscore. Then we can use the word as to indicate that the view select query, or we call that the source, is coming next. After your create statement, you would need to put a go statement in there for batching, because as we know, create statements must be alone in a batch. So a view, like a table or any other database object that you create, you just need to create it once and then you can call on it later. So let's take a closer look at this select statement that generates this particular view. So we're selecting some fields from the song table. Song ID, title, release date, band ID, and we also have this field band name that is coming from the band table. So we're performing the join statement between song and band so that we can include the band name. And typically when we create a view around a table that is part of a relationship, the view by convention would also include some lookup fields from related tables. So rather than just displaying the band ID, we choose to also include the band name. So whenever you have a relationship and you're creating a view, it's common to include those lookup fields. Once the view is created, we can use it in the from line of a select query. So it acts just like a table. Let's put this into SQL Server and we'll test it out. So here's my SQL Server window. I'm going to make sure that we're using the correct database first, and then we're going to create the view. I'll just press enter here so that we don't go off the side of the screen. Now before I create the view, I'm going to test out my source query to make sure that it is pulling the data that we want. It's important, to test out things before we commit them to the database. So I'm just executing only the select statement that is going to act as the source of the view, and we can test it out and make sure that we're getting the results that we want to see. So this is our opportunity to make sure that we're performing the join correctly and that we have all of the fields that we want to be part of the view. Once we're happy with that, we can execute the entire create statement. And we'll see that VW underscore song is now stored as an object in the database. If we want to verify that, we can go into our Object Explorer, look under the Views heading, and you'll see that there's a list of views. Here's the one that we just created. So VW_song. So once it's there, we can use it in the from line of a select statement, and we're selecting all from the view. So we execute that. We see we get the same results. But because we're selecting from the view itself, the view returns a table. And we can modify our select statement to select just particular things from this view. So we can do something like this, for example. Where we are only retrieving particular values from the view, or we can use this opportunity to add an order by line. So we're selecting particular values from this data set, and we use this select line to generate the data set. So the concept is similar to when we talked about selecting from a subquery. The only difference is the source of the subquery is stored in this view object. So once we have the view object, some of the things that we can do with it, the first and most obvious is retrieving records from a view. So we can retrieve records from a view just the same way that we do in a table. You can use a view in a join query. You can use it in a nested query. You can do anything to it that you would do with a typical table. You can also modify table data through views, but there's a catch to that. So you can use a view to insert, update, or delete, but only if you're only affecting one of the underlying tables. So let's take a look at an example running an update query through the view. Now before we start, I'm just going to select all the data from the view so that we can look at what we've got. Okay, so let's say that we want to make some updates to this data. Let's take a look at record 1. We've got a song called Swim by a band called Dizzy. Now, if I want to change the song title, I can use the view for that. If I want to change the band name, I can use the view for that as well, because both of those values are retrieved through the view, but they're both being retrieved from two different underlying tables. So I can change the song title, or I can change the band name, but I can't change them both at once. Because if I write an update statement, the update statement can only update one table at a time. So if an update statement is trying to update values that are stored in the song table and also in the band table, then that will break down. So let's do a little demonstration to show you what I mean. If I'm going to perform an update through the view, and I'm going to change the song title to, let's say, walk instead of swim, where band ID equals 3. Now, in this case, the band ID of 3 is going to affect all of these records, right? So we're going to change several song titles. We're setting the song title for all of those. Now, if I just wanted to change one song title, then, I want to be more specific and go to song ID. So we'll change just this one with song ID equals 1. And if I test this out, you'll see that it successfully updates through the view. The song title is now Walk. It also updates the underlying table, Song. So if I select all from Song, you'll see that updates as well. The view does not actually store the data. It's just a way to provide controlled access to the underlying tables. Okay, now let's use that same view to update something in the band table. Same view, and we're going to set band name equal, let's see, sunset. So we're going to find band 3, and we're going to change the band name. Now before I do that, let's take a look at what happens if I try to change the band name for a particular song. If I look for song ID 1 and I change this band name, what's going to happen to this record? We would want the band name to change. It's the same band. Let's take a look. When we take a look after the update, you'll see how that did successfully affect the band table. So this is something interesting when you look at views, is this wouldn't work if we were doing it through updating band, because the band table doesn't have a song ID, but it does work if we use the view. Okay, now let's say we wanted to set it back. So we're going to change it back to the song title of Swim by the band Dizzy. I'm going to perform another update statement. But you'll see what happens if I try to do both at once. Both of these use the same where line. So if I use that same where line, song ID equals 1, you'd think that this would work. But watch the error message that we get. It says it's not updatable because the modification affects multiple base tables. So this is the clause that I was mentioning earlier, that you can perform action queries through a view. So you can update, you can delete, you can insert through a view, but only if you are updating, deleting, or inserting into one base table only. So I can perform an insert through the view if I want to put in a new song for an existing band. Or I can perform an insert through the view if I want to put in a new band, but not a song yet. But I can't do both at the same time. And that tracks with what we know about update statements and the fact that you can only update one table at once. Now, if we want to make changes to views, we can use an alter statement. And the way that an alter statement works with a view is that it has the exact same syntax as a create statement. The only difference is we use the word alter instead. So when you alter a view, you have to provide a new source query. So that is how we change what's existing. Your other option is to drop a view and then run another create statement. The problem with that option, of course, is that if your view is included or referenced by other objects, you may have trouble dropping it. And as our databases get more and more complex, the solution of drop this and remake it, it becomes very tedious because all these objects reference each other and become interconnected. And you end up having to drop and recreate, multiple different objects, which isn't very efficient. So we need to get comfortable with altering existing things. We do have a drop syntax. We say drop view and then provide the name of the view. One thing I do want to point out, that dropping a view does not affect the source tables. Remember that a view is kind of like a virtual table. It does not actually store data. So the view is just there to retrieve data from existing tables. Now, if we perform our alter statement, let's say, I want to add, say, a where line here. Where band name So we can add different logic. We'll execute this here. And now when I select from the view, you can see that I don't have any songs showing up with the band name Dizzy. And the reason for that is because our update statement here failed. If we look at what's still in our view, our view isn't showing any records now. So that where line is being applied. Our update statement here failed because we tried to update two different tables at once. In order to perform these updates successfully, we have to perform two separate update statements. So I'm going to write one update statement that updates the song table through the view, and then the next update statement that updates the band table through the view. You can execute both of these. Now notice 0 rows affected. You might be wondering why it didn't work. Well, keep in mind that our view right now returns 0 records. We're trying to update a view with song 1. Song 1 does not appear in this result set. So we can't update something that is not part of it. Let's alter our view again to remove this clause. I'm just going back and forth with what our view actually represents here. Now our view shows all the songs. Now that we have some songs in the result set, we can update values. So that's another thing I wanted to point out, using a view when you're making changes to the data. Song ID 1 was not removed from the song table, but it was removed from this view. So if you try to update or delete through a view and that record isn't part of the view's data set, then you can't update it, even if it is in the table. So that's something important to keep in mind. Now that we've run the update statements and our band name is back, now we can test out our where line to prove that we can use where lines and other types of logic in my view. Okay, I'm going to do one more view example, one that uses a calculated column. So let's create a view that shows us every band and the number of songs that they have. I'll just pause while I type. So I've written my select statement that's going to act as the source of the view, but like I said, we want to make sure that we are testing this stuff out first. So I'm selecting the band name and a count of that band's songs. So we have an aggregate function with a group by statement. I've chosen a left join to include bands that have 0 songs. So let's execute this and see what we get. So we have band names on the left, and notice I've not written an alias here for the column name just yet. So in this case, our logic is correct. We can go in and verify that by looking at the data. If I don't provide an alias here, let's see what happens when I try to create this as the source query of a view. So I'm going to indent it one line and add my create view statement. So we'll do some batching work here to eliminate that error. And I just need to refresh my IntelliSense. So you'll notice that we're getting an error message here. No column was specified for column 2. So this is the reason why we always provide an alias for calculated columns. So we can see it in the display. But if we were to create the view with these two columns, we would have no way of referencing the second column because it doesn't have a name. So the view doesn't allow you to leave that without an alias. So we'll give it a name here. This will allow us to create the view. And now that data set is stored with that view. So I can say select all from that view. Now the nice thing about using a view is that it can simplify your queries. And this is going to become really handy once we get to the client portion of this course, because now when we're writing our SQL queries from our C# program, we won't have to write all of the logic. So rather than writing a very complicated select statement with a join and a grouping and an aggregate function, all we'll have to do is write a very simple select all from this. And we can keep all of the logic hidden and provide that level of abstraction so that people that are trying to access our data don't necessarily need to know or understand or be privy to the actual details of how our tables function. And once we have this data, of course, we can start applying our other things like order by, so that we can make the data set to our liking. We can add a where line, only show bands who have at least one song. So we can use our view, which is generated from this source query. So some best practices to think about when you are creating views. The first is it's best to always select all the fields from the underlying table. So typically a view is based around one table and then includes lookup fields or calculated fields that are generated from other tables or functions. It's better to eager load it. So what this means is it's better for the view to have a lot of data in it because we can always use our select statement later to reduce the amount of data that we see. So we call that eager loading to get all the information we're likely to need on our first trip to the database. This reduces the chance that we'll have to go back to the data store. So for example, our original view, the VW song one, we would want to write that so that it would contain all of the fields from the song table and then also add in a lookup field. And then another thing that we would do commonly is to include one or more summary fields. So for example, if you have a first name field and a last name field, it's typical that the view would include a full name or a formal name to avoid doing calculations when you're selecting from it. So we can include all kinds of logic, calculated fields, functions, anything that you might want to hide from the people who are using your view logic. Okay, so that's all I have to say for now about views. There is a practice exercise in Blackboard that allow you to practice some more, and this note will be made available to you on Blackboard as well. Have a great day.